Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is a templated variant. Before proceeding, make sure that you have already watched these other videos first. A templated variant variable is C++ 17's alternative to the C language's union. This xvar is a templated variant variable, which can hold either an int, a float, or a string. At any given point in time, a templated variant variable contains data corresponding to only one of its potential types. You can query which of those types it is. Later on, the templated variant variable can change to contain data corresponding to one of the other types. If you're going to access the data that's being stored by a templated variant variable, then you'll need to know which of these potential data types its data currently corresponds to. You must specify that type's name to a templated accessor function called get. Or you could equivalently specify that type's position within the list of potential types. If you're incorrect about which type you specify, then C++ will throw an exception. If you're not sure about whether or not you're correctly guessing the templated variant variable's current type, then you could use getIf instead of get. This getIf will access the data indirectly as a returned pointer to the data. Or if you are guessing wrong about the data type, then this getIf will return a null pointer instead of throwing an exception. In the rare case of an exception that occurs during the assignment of a templated variant variable, it is possible for that templated variant variable to have no data at all. In that situation, there is a valueless by exception function that you can query to see if this has happened. A templated variant variable that is uninitialized will use the first of its potential types. For when the variable might be uninitialized, that first type must have a default constructor. Because that default constructor requirement might be inconvenient, C++ provides a dummy type that you could specify as the first type. When working with a templated variant variable, this literal value must unambiguously match exactly one of its potential types. If a literal could match more than one of them, then you must manually disambiguate by using this in-place index dummy. A templated variant variable can be copy constructed or copy assigned. If the templated variant variable used to have an object value before being assigned to something else, then that prior object value will be properly destructed. If you're assigning from a new object, then you can either manually program the compiler temporary, as we're doing here, or you can use mplace to have the system do that automatically. If two templated variant variables had been defined using the same exact list of potential types, then they can be compared using equality or ordering operators. If those two variables are currently both using the same type, then the equality and ordering operators would compare their values just as normal variables would. But if the variables are currently using different types, then those two variables are considered to be unequal, and the ordering of those two variables will depend on the order in which the types were listed in the variable definitions. To have a switch that does a different action based on which type is being used, create this visitor object.